So we continue with the point defects in solids, and the second type of these defects seen in solids, they're known as non-stoichiometric defects. Now why are they known as non-stoichiometric defects? The reason is that as a result of this defect, as a result of these imperfections जो भी हम under this heading पढ़ेंगे, what happens is that the ratio of the cations and the anions, that becomes different from that indicated by its chemical formula. For example, अगर हमारे पास AB2 type solid था, उसमें 1:2 ratio होता cations and anions का, इस defect के बाद it will not be 1:2. That ratio gets disturbed, that stoichiometry gets disturbed. That is why these defects are known as non-stoichiometric defects. Now a defect, this can result either by metal excess or by metal deficiency. या metal ions ज़्यादा हो जाएंगे या metal ions कम हो जाएंगे. We'll do the first type, A, metal excess defects. And metal excess भी दो reasons की वजह से हो सकती है. The first can be by anion vacancies. Metal excess होना कैसे? The first thing is by anion vacancies. You have this crystal lattice in front of you. M plus इसमें metal ions है, cations, and X negative इसमें anions है. What happens here is that a negative ion goes missing from the lattice site. That is the defect. The defect is that the negative ion, one of the negative ions, it can be more also, goes missing from the lattice site. Now you see an electron in this side, that is because the electrical neutrality of the crystal lattice is to be maintained. Point number 3, I've already written that it is mostly seen in those solids which already show Schottky defect. Now another information about this is that यहाँ vacancy में हमने electron जहाँ पे है इसको F center लिखा हुआ है. This F stands for a German word, FARBE. I do not know how they pronounce it in their language, but all my years I have read it as Farbe, and Farbe means color. So because of these F centers, these solids which have anion vacancies, which lead to metal excess defect, which is a non-stoichiometric defect, they have a certain color depending on which crystal this is. Like sodium chloride का crystal अगर आप लेंगे and आप उसको heat करेंगे in the vapors of sodium itself, sodium vapors में ही उसको heat करेंगे, this defect takes place in that crystal lattice of NaCl, and this defect imparts a yellow color to that crystal. Similarly, अगर KCl में ये defect हो जाए, the defect, this anion vacancy की वजह से metal excess defect, it imparts a violet color in that crystal. That is why these centers are known as F centers. They are the color centers. Now the second reason जिस वजह से metal excess हो सकता है is the presence of an extra cation in the interstitial site. Not just one, there can be two, there can be three. The presence of these extra cations leads to the metal excess defect. Now what happens, ये जो extra cation आएगा, since it's a cation, it will occupy the interstitial void. Now because of this positive charge बढ़ गया, what makes it neutral? For electrical neutrality, we have equal number of electrons occupying other interstitial sites. Now these defects are usually found in those solids which already have Frenkel defects. I've given an example below. जैसे zinc oxide है, इसको अगर आप बहुत ज़्यादा heat करोगे, it loses oxygen, leaving behind Zn2+. That Zn2+ will occupy an interstitial site. That is how generally this defect occurs by excessive heating. And दोनों ये defects, दोनों metal excess defects जो हैं, चाहे वो anion vacancy से हो या extra cation से हो, they make these solids behave as semiconductors, because as you saw in both of these slides, there are free electrons there, and because of the moment of these free electrons, they will conduct electricity. They're not as good as conductors, they're semiconductors. The next kind of a non-stoichiometric defect, it can occur by metal deficiency. If a deficiency happens inside the crystal, deficiency of a metal ion, the defect is a non-stoichiometric defect. Now the first point is very important here. It occurs only if the metal shows variable valency. Transition metals, they show variable valency. Iron plus 2b होता है, iron plus 3b होता है. Why is that necessary? As you can see, A plus यहाँ से गायब हो गया है. A metal ion is missing from here, and which means कि charge disturb हो गया. Electrical neutrality of the whole crystal is being disturbed. To balance that electrical neutrality, we have a A2 plus here. But see, this is A, this is not C. It is A here also. It must have been A plus here. The whole crystal has A plus as its cations, and this is occupied by A2 plus, the same element with oxidation state +1 all around the lattice, and this one with oxidation state +2, balancing this ion, this space in which there must have been A plus. Found in transition metals, for example FeO, iron oxides, iron sulfides, nickel oxides. Due to this defect, such compounds are always non-stoichiometric. Like, you don't have a perfect ratio of 1:1. By the chemical formula this might seem like 1:1, but it is not 1:1. The ratio is, we have iron 0.96:1 of oxygen. That is a non-stoichiometric defect. That's it.